Hello and welcome. This is the first video in a multi-video series I'm going to make. It relates to my undergraduate project. It has to do with the sums of powers of integers. I'm just going to do this first video as a basic introduction and maybe why I could convince you that this is actually pretty interesting. So let's say that someone asks you, what is 1 plus 2 plus 3 plus 4 plus all the way 99 plus 100. You might say, I'm not going to do that. Even if you had a calculator, it would still take you a while. Is there a faster way to compute this? Well, it turns out there is. And I'm going to show you how you could show that this whole thing is equal to 5,050. You could probably do it in your head in a matter of 30 or so seconds, versus if you were to try and do this with a calculator, it would probably take you at least a couple of minutes. So let's begin. So what we want to know, let's just call this S. Let's just give this whole series a name. Let's say that S equals 1 plus 2 plus 3 plus all the way up to 100. Well, we could change the order of this and that wouldn't change the sum. So instead of adding 1 plus 2 plus 3 all the way to 100, let's add 100 plus 99 plus 98 down to 1. And that would be the same thing, just going in a different direction. What happens if I were to add these two things together? So what if I took this, sorry, my lines are a little crooked today. I took this and I added them. Well, if I add the s's, I'm going to get 2s. 100 plus 1 is 101. 2 plus 99 is 101. 3 plus 98 is 101. These are all getting added. I think you see the pattern. 100 plus 1 is also 101. Well, my question is, how many 101s are there? Well, there's 1, 2, 3. There's 100 of them. So this is really 2s is equal to 101 100 times. And we can solve for s. S is equal to 101 times 100 over 2. Okay, that's actually pretty easy to simplify. That would just be 101,000. Oh, I'm sorry, that's not correct. 10,100 over 2, which is 5,050. And it turns out that didn't really take so long. Not very long at all. Let's generalize this. Maybe we could generalize this, because what if I instead asked you, what is 1 plus 2 plus 3? Not up to 100, but up to 1,000. Could you still do it as quickly? How about 10,000 or 100,000? What if it's just n? Well, the same method applies. If I say that s equals 1 plus 2 plus 3 up to n, I can say the same thing over here. And if I pair these, you can see this is 2s. This is n plus 1. Oops, sorry. It's n plus 1. This is 2 plus n minus 1 is n plus 1. 3 plus n minus 1 is n plus 1. N plus 1 is n plus 1. So how many terms do I have? I have 1, 2, 3. I have n of them. So this is the same thing as saying 2s is equal to n plus 1s. That will give you s is equal to n times n plus 1 over 2. My God, I can't circle anything today. So this is the general formula for just summing numbers from 1 to n. If you plug it in, you'll get it right. Let's do a few more tests. Say I wanted to do 1 plus 2 plus 3 plus 4. Does it work? Well, in this case, you have n equals 4. So you'd have s equals 4 times 5 over 2, which is 10. And let's see, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. Looks like this formula does work after all. But I have a question that I'd like you to ponder. I'm about to end this video. What if I said s was equal to 1 squared plus 2 squared plus 3 squared plus 4 squared plus ... plus n squared? Do you think there's a nice formula for, so let's say that this is S1 and this is S2. Do you think there's a nice formula for S2? What if I had S3, which is 1 cubed plus 2 cubed plus ... up to n cubed? What if I had SR is 1 to the r plus 2 to the r plus ... plus n to the r? Do you think there's nice expressions for all of these? Well, it turns out there is, and if you were to generalize it, you're eventually going to end up at something called Faulhaber's formula. And I will eventually talk about that, but I'm out of time for now. See you in the next video.